Here we have a SAT math problem. Okay, let's go to the question. In the xy plane above, line L is defined by the equation 3x positive 4y equals to 12 and line segment OP is perpendicular to line L. What is the length of the line segment OP? Okay, in the given figure, we have to find the length of this line segment OP over here. And also the question says the line segment OP is perpendicular to line L. Since this line segment OP is perpendicular to line L, we have a right angle over here. And in any xy plane, x-axis and y-axis will intersect at right angle. So here we have right angle. And now let me take this is point A and this is point B. Actually, point A represents the x-intercept of the line L and point B represents the y-intercept of the line L. Okay, now we can consider the triangle OAB over here. It is a right triangle. Now let's plan how to solve this problem. That is how to find the length of this line segment OP over here. Using the equation of line L, I can get the x-intercept A and y-intercept B of this line L. Using the x-intercept and y-intercept, we can get the base OA and height OB of this right triangle OAB. So using this base and height, we can get the area of this right triangle OAB using the formula base times height divided by 2. And there is another way to get the area of the same right triangle OAB. That is, we can consider this line segment OP as height because it's a line segment perpendicular to one of the sides of the triangle. So we can consider this OP as a height and this AB as a base. So in that way, we can get the area of the same right triangle OAB. So the areas we get in both the ways can be equated and we can find the length of this line segment OP. Okay, now my aim is to get the x-intercept and y-intercept of this line L so that I can get the base of the triangle and the height of this right triangle. Okay, now let me take the equation of line L, that is 3x positive 4y equals to 12. Now to get the x-intercept, that is point A, what we have to do is we have to plug in y equals to 0. When I plug in y equals to 0, this 4 times 0 will become 0. Then I'm getting 3x equals to 12. When I divide both sides of this equation by 3, I'm getting x equals to 4. So the x-intercept is 4, 0. That is point A over here is 4, 0. Then we have the value 4 on the x-axis over here, which is the x-coordinate. And so the length of this line segment OA, that is the base of the triangle, is 4, the value we have over here. Okay, now let's get the y-intercept of this line. For that, we have to plug in x equals to 0. When I plug in x equals to 0 over here, 3 times 0 is 0. Then we get 4y equals to 12. When I divide both sides of this equation by 4, I am getting y equals to 3. So the y-intercept of the line is 0, 3. So this is point B over here. That is 0, 3. And we have value 3 over here at the point B. That is a y-coordinate over here. So then the length of this line segment OB is 3. That is the height of the triangle is 3. In this right triangle OAB, this side AB represents hypotenuse because it is opposite to right angle. And for the remaining two legs, we have the lengths 3, 4. Then this OAB is a 3, 4, 5 right triangle. That is when the lengths of two legs are 3 and 4, then the length of the hypotenuse, that is the length of this side AB must be 5. Okay, now what we can do is we can get the area of this right triangle OAB taking this 4 as the base and this 3 as a height. And the formula to get area of the triangle is the base times height divided by 2. Now to get the area, we have to plug in this 4 for base B over here and we have to plug in this 3 for height h over here. Then we get 3 times 4 divided by 2. Okay, so this is the area of this right triangle OAB. And as I said earlier, we can get the area of this right triangle in the another way. That is, we can consider this OP as a height and this AB as a base because this line segment OP is perpendicular to one of the sides of this triangle AB. So we can consider this OP as height, and in that case we have to consider this side AB as the base. Okay, here the base of the triangle in this case is 5. So we can plug in 5 for this base B. We get 5 times and the height of the triangle is given by the length of this line segment OP. I do not know the length of this line segment OP. That's what we have to find. So we can plug in this OP as it is for height over here. That is 5 times OP divided by 2. Okay, here both the stuff represent the same thing. That is the area of the right triangle OAB. So we can equate them. So here 2 goes into 2 1 times, 2 goes into 4 2 times, 3 times 2 is 6. On the right side we get 5 times OP divided by 2. Our aim is to solve for OP. For that we have to get rid of this fraction 5 over 2. Let me multiply both sides of this equation by the reciprocal of this 5 over 2. That is 2 over 5. Okay, let me do it. Let me do the same thing on the left side as well. Okay, here this 2 will cancel, this 5 will cancel out. 2 times 6 is 12, that is 12 divided by 5. On the right side we have OP. Okay, when I divide 12 by 5, I am getting 2.4. On the right side we have OP. Okay, here I got the length of the line segment OP, that is 2.4. We find this 2.4 in answer choice B. The correct answer choice for this question is B.